Okay, here we go, folks. We're back at it. Today we pick up just with this little section. We just want to do these problems, and that's it. Okay. And so we're going to pick up with the idea of identifying more limits. Calculus is really broken into three main categories. And number one is finding limits. Number two is finding derivatives. And then number three is determining integrals. And so you don't know anything about integrals yet. You're going to learn about that. But the first two you do, right? You got, this whole derivative thing and limit thing. Well, here's some interesting limits that we want to be able to identify. Okay, and we proved that the derivative of sine is cosine. We use this thing called the Sandwich Theorem, and this whole cool proof that happened before. And from that, we came up with a couple really important limits. Do you remember what the limit was as theta approaches 0 of sine of theta over theta? It is 1. You need to somehow commit that to memory. Okay. And then the cosine of theta minus 1 over theta ended up to be 0. Yeah. Okay. So we're going to use those in order to evaluate these limits, and we're going to show it algebraically. Okay, we're going to show it algebraically. So you must show your work here. For some reason, this is challenging for a lot of students, and I don't understand why. So you need to help me out as you have questions. Be specific where you're getting confused, and let's be patient with each other. Okay, this one says evaluate the following limit. Limit as theta goes 0 of sine of 2 theta over theta. Okay, and so what I would like to see in this problem is I would like this to be the limit as theta goes to 0 of sine of 2 theta over 2 theta. That's what I want, okay? And I'll tell you why I want that. Because here I have theta over theta, okay, sine of theta over theta. Here I have sine of 2 theta over 2 theta. See that the angle here is theta? The angle here is 2 theta. As long as the angles are the same, then the limit comes out to be 1. But if you look at my original problem, are the angles the same? They are not the same, okay? Now, here's the thing. I can't access this because I'm taking the sine of it. So I can't get at that 2. I can't, like, divide the 2 off. I can't cancel off the thetas, as some people might want to do. But I can get access to the bottom. And so here's what I'm going to do. I'm going to multiply by 2 over 2. And that's going to allow me to rewrite this limit as theta goes to 0 of sine of 2 theta over 2 theta times, anybody know what I have left? 2 over 1. Okay, so what I did in this scenario is I used the commutative property of multiplication. I put the 2 over with the theta, which left me with a 1 right there. And so I get this. And we do it all the time, don't we? Commutative property of multiplication. For example, 5 over 6 times 3 over 5 times, let's do 6 over 3. I mean, you guys look at that all the time as 5 over 5 is 1, 6 over 6 is 1, and 3 over 3 is 1, right? You have no problem doing that, right? That's really using the commutative property of multiplication and reorganizing things as 1 over 1. So I can now determine this limit. What is the limit as theta goes 0 of sine of 2 theta over 2 theta? 1 times, which is 2. What's this limit? 1. There you go. No. Okay, so I got it. So suppose you were to write it like this. So you're to extract the 2, put the 2 on the outside. And you say, well, that's 1 times 2, so that's 2. Although you came up with the correct limit, the fact is that this is not appropriate math work. You can't take the 2 out there because you're taking the sine of the 2 theta. You would have to inverse sine first to get at the 2 theta. So no, you cannot do that. That would be what we call voodoo math. So a lot of times people look at this problem, and if they were to get on the test, they'd write down 2. They could see the answer is 2, but can they show their work? And many times they cannot. So you must show the work correctly. Yes. How I got from here to here. Okay. It's suppose I had 2 over 3 times 5 over 4. Don't you agree that that's the same thing as 2 over 12 times 5 over 1? Good boy. Yeah, because 3 times 4 is 12. Times 1 is still 12, right? Okay, let me try one more. Okay, how about this? 2 over 3 times 4 over 5. This is the one I've tried in the past. Isn't that the same thing as 2 over 5 times 4 over 3? Isn't that the same thing as 4 over 5 times 2 over 3? I can do that, correct? Hi there, guys. How you doing? Joey, you owe me a calculator, right? Awesome. I would love to do 2 cents with Gens, but can I not do it today? Can we do it tomorrow? All right, how about you stop by tomorrow at 9:30, and I'll be ready to go, and bring your calculator too. Awesome. See you then. We got a date. Let's do it. So we're simply using this idea that 5 times 3 is the same as 3 times 5. The reason why it's not clicking for us is because when we see fractions, our brains go to mush. Okay, it just everything all of a sudden just falls out. You know, we're just like, what can we do? What can't we do? But we're just simply changing it. Let's try another example and see if that works for you. If that doesn't work for you, we'll try to back up here. Okay, I forgot an important step is that when you go to determine the limit originally, you should plug in 0. And if you plug in 0, what is 3 times 0? And what's the sign of 0? Over 5 times 0? 0. And so the big question is, what is 0 times, or 0 divided by 0? That's an indeterminate value. We don't know what it is, but we're going to figure out what it is. And so as you look at this problem, you need to start to think about, what do you want to see? And some people might say, well, I want to see sine of 5 theta over 5 theta. We can't change that 3 to be a 5, can we? But we could change this 5 here to be a 3. We could. So I want to get sine of 3 theta over 3 theta. That's what I'd like to get, okay? And so we'll show you how to do it, okay? It's no big deal. We have the limit as theta goes to 0 of sine of 3 theta over 5 theta. Now, I don't want a 5 there. I want a 3. So I'm going to multiply top and bottom by 3 over 3. That's the only option. Why does it have to be the same number over itself? Because it's 1. So you got to multiply by 1. That's first of all very important. Got to multiply by 1. And then I chose 3 because I want a 3 theta. Okay? So you can see I have the sine of 3 theta over, and I'm simply going to switch the 3 and the 5. And you're like, well, that's voodoo math. It's not. It's not at all. It's just saying that 3 times 5 is the same thing as 5 times 3. Multiplication is commutative. We can move them all around. Yeah, through multiplication. It's 5 times theta times 3. You know, so 5 times theta times 3 is the same thing as 3 times theta times 5, right? Okay, so I'm going to switch the 3. So I got 3 theta times what's left? 3 over 5. And so I have the limit as theta goes 0 of sine of 3 theta over 3 theta times 3 over 5. So what's this limit right here? It's 1 times 3/5 is. So again, I get that you can look at it from the beginning and identify it's 3/5, but you have to show your work properly or you will not get the points. You got a good guess. You got a really good guess. A lot of times it just ends up being this number divided by that number. Not all the time, but lots of times. Okay. Yeah, there's a lot of ways you could write it. You could multiply the 3 back over to, you could write it as like 3 sine of 3 theta over, 5 times theta times 3. But then in order to see it, you'd want to separate it again, right? Okay. Let's try the next one, okay? First I'm going to plug in 0. What's the cosine of 0? 1 minus 1 over what's the sine of 0? 0. So I get 0 over 0. That's a problem. Okay, I always try direct substitution right away. If it doesn't work, then try something else. Okay. And so I'm going to look at this, and I don't like what I see at all. Something rings a bell to me. This cosine of theta minus 1, I need that to be over what? I need it to be over theta, but I don't have a theta in the denominator. I have a sine of theta. Well, if I see the sine of theta in the denominator, what do I want in the numerator? Theta. Yeah, I want just a theta. I showed you this earlier, and if you don't remember, I'll show you again. We have the limit as theta goes to 0 of, it turns out that the reciprocal is true as well. Okay. Turns out that the reciprocal is true as well. So I have the limit as theta goes 0 of cosine of theta minus 1 over sine of theta. And so I'm going to do something really tricky here. We're going to see if you guys can follow this. What I really want is I want a theta in the denominator. So I'm going to multiply by theta over theta. Now produce for me the limit as theta goes to 0 of, I'm going to let these two switch places. Why am I so popular? Okay, because multiplication is commutative, I'm gonna move these two back and forth. So I end up with the cosine of theta minus 1 over what? Theta times what's now in the denominator? Sine of theta. And in the top, theta. Very good. Okay. What's this limit? What's this limit? What? Well, what's the reciprocal of 1? Yes, really good questions. I appreciate your questions. Okay, this one doesn't work out very well at all. So we're going to do the limit as theta goes to 0 of tangent of 5x over sine of 5x. Oh, I'm sorry, sine of 2x. It's a bear when you got to use those erasers, isn't it? It's like... Oh, I'm sorry. So yeah, well, yeah, there we go. Okay. Limit as x goes to 0 of tangent of 5x over sine of 2x. There we go. All right. X is a variable just like theta. We can interchange variables. You can even use u. You can use r. You can even use g, q. Use beta. You could, yeah, you go, use a heart. Go ahead. Yep. Variables are wonderful. You're done already? All right. Great. Thanks, Zane. You're a good kid. All right. Let's try plugging in 0 first. What's the tangent? What's 5 times 0? And what's tangent of 0? It is 0. And then 2 times 0 is 0, and the sine of 0 is... So I get 0 over 0, which is an indeterminate value. We don't know what it is. So we're going to have to try something else. Now, I have this sine of 2x in the denominator, but the tangent of 5x, I think that there might be something useful I can do there. So what I'm going to do is the limit as x goes to 0 of sine of 5x over cosine of 5x over sine of 2x over 1. I rewrote tangent as the sine of 5x over the cosine of 5x. The reason why I chose to do it is because I do not see up here anything that has to do with tangent. But I do see things that have to do with sine and cosine. I'm going to multiply by the reciprocal. Okay. And so I now have this. The limit as x goes to 0 of sine of 5x over the cosine of 5x times 1 over the sine of 2x. Okay. No, not at all. So as you look at this situation that I have here, the limit is x goes to 0. Watch what happens if you start plugging in your zeros, okay? 5 times 0 is 0, and the sine of 0 is 0. 2 times 0 is 0, sine of 0 is 5 times 0 is, and the cosine of 0 is 1. Cosine of 0 doesn't really cause an issue for us, does it? Like, you get 1. I mean, that's a good deal. So I like the cosine of 5x. I like it a lot. But what I don't like is I don't like the sine of 5x and the sine of 2x. What I would like to have is something in this numerator right here. What would you like to have in that numerator? Yeah, what do you want? Nope, we want something other than 2. We want... No. Want a 2x. I need this same thing. Okay. All right. Now, I don't want cosine of 5x in the denominator. I just want 5x. So I multiply top and bottom by 5x. Yeah, yep. Okay, so if you look at this situation right here, okay, at the very beginning, when we first started out here, does everybody understand why we went 2 over 2? Because what did you want in the denominator? You wanted 2 theta. You wanted 2 theta. You have a 2 theta here, you need a 2 theta there. Look at what you have here. You have a 2x. So what do I need here? A 2x. No, they don't. You guys, I can't just drop off the cosine. I can't just say, well, I'm just going to leave a cosine all by itself. You can't say, well, I'm going to cosine of 5x, that's like cosine times 5x. And so I'm going to write cosine over 1, and I got 5x over 1. No, totally make believe. This is an operation. This is not multiplication. This is not cosine times 5x. This is cosine of. You can't separate them. Can't separate them. I want sine of 5x over 5x. Now I have a 5x. Let's worry about the cosine in a second here, okay? So notice what I'm going to have. I'm going to erase this green. So we have cosine of 5x. I'm going to grab that 5x. Where do you think it's going to go? It's going to go right over there, okay? I'm going to grab this 2x. Where do you think it's going to go? It's going to go right there. Now, don't worry about the rest of the stuff. It'll get figured out. So I have the limit as x goes to 0 of sine of 5x over 5x. Oh, that makes me so happy to write that, because we know what that is. That's just, right. So this is gone, and that's gone. Well, right, it's right here right now. I'll put it down there in a little bit. But I'm not done yet, right? So I'm going to wait. Now, what do I write here? 2x over sine of 2x. Hey, I really like that because that's just 1. Great. So the 2x is gone and the sine of 2x is gone. Okay, so I have some things that are still left, and this, I guess the 1's kind of gone as well. What's 5x over 2x? 5 halves, right? So we also have 5 halves. And what haven't we accounted for yet? Right, so we have a 1 over the cosine of 5x. So they're all gone, right? So let's evaluate. Limit as x goes 0. Sine of 5x over 5x. 1. 1 times 5 over 2 times. What's 5 times 0? 0. What's the cosine of 0? 1. What's 1 over 1? And so what do we get? What's that? All right. I got a worksheet for you. No more book assignments for you.